Hi, welcome to Quick Maths. This topic is on geometry jargon, which includes congruence and similarity. I will start with types of angles. Acute angle is an angle strictly between 0 and 90 degrees. The right angle is exactly 90 degrees. The obtuse angle is strictly between 90 and 180 degrees. And the reflex angle is strictly between 180 and 360 degrees. Next, I wish to talk about types of triangles, starting with those that are angle related. The acute angled triangle has all its internal angles less than 90 degrees. The right angled triangle has one internal angle being 90 degrees, and the obtuse angled triangle has one internal angle being larger than 90 degrees. And in relation to length of side, the equilateral triangle has all sides having equal length. The isosceles triangle has two sides having equal length, and the scalene triangle has all sides with different length. Now let's take on tutorial question 1, stating which ones are true and which ones are false. 1. All acute angled triangles are equilateral triangles. This is false. 2. All equilateral triangles are acute angled triangles. This is true. 3. All isosceles triangles are acute angled triangles. This is false. 4. An isosceles triangle can never be an obtuse angled triangle. This is false. For completeness, attached herewith is a matrix that says it all for types of triangles. Moving on to the subject of congruent triangles. They are triangles that are identical or a perfect match to one another. Here are the scenarios. As in the matrix, when three sides are the same, the triangles are congruent. When two sides and the angle between these two sides are the same, the triangles are congruent. Thirdly, when the two angles and the side tied to the same two corresponding angles are the same, the triangles are congruent. The bottom row of this table is an extract from the table in the previous slide. It states that even when two sides and the angle not in between are the same, the triangles are not necessarily congruent, except when the triangles are right angle. In this case, when the corresponding side, the hypotenuse, and one right angle not in between are the same, the triangles are congruent. Also from the first slide on congruent triangles, when three angles are the same, the triangles are not necessarily congruent, except when one of its sides with the same two corresponding angles are the same. In math, when all three angles are the same but the sides are not, these sides would automatically be proportionate to each other. And such triangles are known as similar triangles. Congruence and similarity is not just limited to triangles and can be expanded to any polygon. As in the example, A and B are congruent polygons. B and C are similar polygons, much as A and C are similar polygons. With similar polygons, when its width or height component is scaled by x, its area will scale by x squared. Also, congruence and similarity are not limited to 2D objects. They apply to 3D objects too. As an example, A and B are congruent shapes, and B and C are similar shapes, much as A and C are similar shapes. With similar shapes, when its width or height component is scaled by x, its volume will scale by x cubed. Tutorial question 2. Which triangle below is truly always congruent with A? The one and only is D. Tutorial question 3. The original plan was to build an owl-shaped fencing that occupies an area of 1800 meters square. There is, however, not enough fencing material. So, the builders had decided to build a fence with the tip to tip of the owl's wings being scaled down by threefold, keeping all other dimensions in proportion. What is the resultant area covered by the scaled down owl? With its fifth dimension scaled to a third, its area will scale to a third to the power of 2, which comes to 1/9. Hence, the resultant area is purely 1/9 times 1800 meters squared, and this comes to 200 meters squared. Tutorial question 4. A three-dimension solid metal sculpture of a horse weighs 500 kilograms. The metalsmith decided to build one similar horse using the same material but at only 0.1 in height against its original for his son. One day, the son put the horse he received from his father on a weighing scale. What do you think is the reading? When its height dimension is scaled to 0.1 of its original, its volume as well as its weight will scale by 0.1 to the power of 3, which is equal to 0.001. Hence, the reading should be at 0.001 times 500 kilograms, and this is 0.5 kilograms. That's all on geometry jargon. If this has been beneficial to you, do seek out our other videos under the KT tutorial channel.